Alright, so this video we're going to look at quadratic functions and quadratic inequalities. We're going to learn how to graph quadratic functions, learn how to find the vertex, x, y intercepts. We're going to learn how to convert them between the different forms. For college algebra class, you'll see there's two forms for a quadratic function, and we'll learn how to convert from one form to the other. So, and we got some application problems. Now, as far as the graphing goes, there's really no way in this video, along with all the other stuff, to show you every possible scenario of the graph in each form. So I'll have a link down in the description of two other videos where I show all the possible outcomes in each form. It's two separate videos, so check those out if you want to get some more practice or more information on graphing these quadratic functions. Alright, so let's go ahead and get started. So here we have quadratic functions. They're going to either open up or down. Now, yes, they do open left and right. That's not covered in this class, college algebra. So the ones that open left and right, that's where the y term is squared. When the x term's squared, it's going to open up or down. So here we have a parabola that opens up. This dotted line, this vertical dotted line through the vertex, that's called the axis of symmetry. This graph is a mirror image. We'll have to use that later on when we're graphing one of them. This point here is called the vertex. That's the minimum value, the minimum y value on the graph. And A is positive. I'll talk about this more, this A positive and A negative, when we get down here to two forms of quadratic equations. And then we have a parabola that opens downward, and once again, here's your axis of symmetry. It's a mirror image. The vertex on this is this is the maximum value, and A is less than 0, or A is negative. Okay. Now, the one thing that you want to remember when you're graphing a quadratic function, and I'll say this again when we get down there when we get to the part on graphing, but whenever you're graphing a quadratic function, you want to always find the vertex first. Okay, find the vertex first. All right. So let's go ahead and look at this. So what is this that we're talking about, this A positive and A is negative? Well, here's two forms of a quadratic equation. We've got f of x equals A times x minus h squared plus k, and the vertex is hk. Okay, there's your h and there's your k. It's nice when it's in this form. It's easy to find the vertex. And then we have f of x equals ax squared plus bx plus c. And the vertex for the x coordinate, okay, for the x coordinate is minus b over 2a, where a is the number in front of x squared and b is the number in front of x. This is your x coordinate of the vertex. Now, don't let this part right here confuse you, this f of minus b over 2a. All this means is whenever you find your x coordinate, you just plug it in for x, and that gives you your y coordinate of the vertex. That's all that means, is to take whatever you get here and plug it into your function for x. All right, so let's go ahead and look at some, and let me also mention about this A positive, where this A is positive, A is negative. So if A is positive, that means the graph is going to open up. If A is negative, the graph is going to open down. So what is A? Well, A is the number in front of the squared part. So if A, see, A is in front of the x, in front of the squared part. See the squared part here and the squared part here. If A is positive, then we know the parabola is going to open upward. If A is negative, we know the parabola is going to open downward. So let's look at some examples of how to convert these things. So we want to rewrite each function in the form f of x equals a times x minus h squared plus k. All right, so let's go ahead. The first thing we're going to do is we're going to have f of x equals x squared plus 6x, and we're going to group those first two terms together. Minus 2, we'll put them in parentheses and we'll leave us a little space here. So you can probably imagine what we're going to do. We're going to complete the square. So remember, to complete the square, we're going to half the number in front of x. So the 6 is in front of x. So we take half of that. That's going to give us 3. And then we square it, and that's going to give us 9. So we add 9. And since we added 9, we have to come over here and subtract 9. Now, don't get this part confused with when you're solving a quadratic equation and you're completing the square. So let's just forget about this problem for right now and come over here to the side. Let me do it in a little bit different color. So if you've got x squared plus 6x minus 2 equals 0. So you've done this before, where you've got x squared plus 6x, leave a little space, and bring the minus 2 over. And then you would half the 6 is 3, square 3, that gives you 9, and you would add 9, and then you would come over here and add 9. So you might be wondering, well, why am I subtracting this 9 here? Okay. Well, if you notice in this problem over here, you're going to the other side of the equal sign. So if you add the 9 on this side, you have to also add the 9 on this side. Okay? But look at this. If I subtract 2 and subtract 9 to both sides, that gives me x squared plus 6x minus 2 minus 9 equals 0, right? Because this over here goes to 0. Do you see how I've got the minus 2 and minus 9? You see that? See, I'm staying on the same side of the equal sign. So if I'm on the same side of the equal sign, if I add something, I have to also subtract it. This right here is the same thing as adding 0. Okay? It's the same thing as adding 0. So I can't just, if I have a function, I can't just add a number to it. Okay? I can't just add 9. That changes the problem up. The only number that I can add to something and get the same thing back is 0. So you can see here I added 9 and I subtracted 9. Well, what's 9 minus 9? It's 0. Okay? So since we're adding 9 and we're staying on the, we're staying on the right-hand side of the equal sign, and I added 9, so now I have to come over here and subtract 9. And that's like adding 0. And see over here, adding 9, I added it both times, but that's because I went to the other side of the equal sign. If I go to the other side of the equal sign, then yes, I'm going to add it. But if I stay on the same side of the equal sign, it's subtracted. Well, and I did forget to put this x squared plus 6x plus 9 minus 2. Okay, so see, I've got this, which is right here, and then I brought this over minus 2 minus 9. So remember, whenever you're converting these things, if you add something, then you have to subtract it if you're staying on the same side of the equal sign. But if you go to the other side of the equal sign, if you add it to this side, then you have to also add it to this side. But in this case, we're staying on the same side. And so that's going to give me f of x equals, now remember, this factors, okay, into x plus 3 squared, okay? So remember, when you complete the square, this part right here, that's going to factor into the parentheses squared, and then it's the square root of this first term, which is x, this sign, and then the square root of the last term. and then that's minus 11. The negative 2 minus 9 is negative 11. And so this is the answer that they're looking for. All right. Now, they don't ask us to find this, but let's just go ahead and do it for fun. Let's find the vertex. So the vertex here, okay, remember, it's in this form right here. So our vertex is HK, HK. So what's the vertex? It's negative 3, negative 11. That's the vertex. Now, you might have thought that the vertex was 3, negative 11 because of the plus in front of the 3, but that's not the case, okay? It's, if you look at this, so let's look at this. We've got f of x is equal to x plus 3 squared minus 11. Now, this is in the form f of x equals a times x minus h squared plus k. All right, that's the form we have it in, this one up here. All right, so if I rewrite this as f of x equals x, now see, I need a minus sign right here. So that's minus a negative 3 squared, because the negative and negative is going to give me the positive. And then I need a plus, so plus negative 11. All right, so you can see here's x, here's my minus sign, and there's h, which is negative 3. And then I've got my plus sign, and then my k, which is negative 11. So it's negative 3, negative 11. Now, let me tell you the easy way to remember it, okay? The easy way to remember this is whenever you get it into this form, h will have the opposite sign of what you see, and k will have the same sign as what you see. Okay, so just remember, h has the opposite sign, k has the same sign. So here the h, that's positive, so it's negative. K has a negative, so it's negative. H is opposite sign, k is the same sign. All right, so now let's look at this one. So we want to complete the square again. So that's going to give me f of x equals 2x squared minus 20x, put that in parentheses, plus 3. Leave a little space. Now, in order to complete the square, we've got to have a 1 in front of our squared term. Okay? And notice here we have a 2 in front of our squared term. So what I'm going to do is I'm going to factor this 2 out. So that's going to give me f of x equals 2 times x squared minus 10x plus 3. So I just factored a 2 out of this first part right here. All right. And so now we're going to half the 10. That gives us 5. And then we square it. 5 squared is 20, 25. So I'm going to add 25. And since I added 25 in here, now I'm going to come out here and subtract 50. All right. So think about that for just a second. Where in the world did this minus 50 come from? Because, well, you added 25. Why are you subtracting 50? Well, if you look at it, really, I added 2 times 25. You see that? 2 times 25 is 50, right? So I added 50, so that means I have to come out here and subtract 50. And so now let's factor this. So that's f of x equals 2 times, and that's going to be parentheses squared. And so the square root of the first term is x, this sign, and square root of the last term. And that's minus, was that 47? And so this is the form you're in. Okay. Now, once again, let's just go ahead and find the vertex. See if you can write the vertex down. So the vertex is what? 5, negative 47. All right. Remember, H has the opposite sign. K has the same sign. All right. So that's converting from this ax squared plus bx plus c to this form. I've seen where this is called vertex form, so you're converting from standard form or general form to vertex form. Okay. All right, and I've got some videos that's just on this. You can check those out. I've just searched my channel probably for converting quadratic equations or something like that. All right. Now, let's look at this. It says for each parabola, determine whether the parabola opens upward or downward and find the vertex, the axis of symmetry, and range of the function. Find the maximum or minimum value of the function and the intervals on which the function is increasing or decreasing. All right, so that's a lot there that we have to find. Now, it may seem like, hey man, you know, this is a lot of work. This is a lot to do. But guess what? By just finding the vertex, you can answer all these questions. All you have to do is find the vertex. And so let me show you how. So let's find the vertex of this one. So the vertex in this one is what? -4, -8. Okay. All right, -4, -8. Now, the next thing that we want to do is we want to graph this thing, but not in any detail. Okay, we don't need any detail to answer these questions on the graph. Really, all we need to know is does it open up or down? All right, so let's see what else we've got to find first. All right, so first, I guess before we write the vertex down, kind of got ahead of myself a little bit. Determine whether it opens upward or downward. Okay, so this opens downward, okay, because of the negative in front of the squared part. And then it says find the vertex. So the vertex is, we got that already, -4, -8. Okay, so there's our vertex. And they want to know the axis of symmetry. Well, remember up here, the axis of symmetry is this vertical line going through the vertex. Okay. And if you remember back when you learned how to do functions, that the equation of a vertical line is x equal some number. Okay, and remember a horizontal line is y equals a number. Okay, so remember that. So the vertex, the axis of symmetry is x equal a number. Well, what is it going to equal? Well, if this is your vertex, it's going to equal the x coordinate of the vertex. Okay, so let's go back down here to the problem. So the axis of symmetry, is x equals, well, what x value is it going through? It's going through -4 right here. So that x equal -4. So there's your axis of symmetry. And then what else does it say? And the range of the function. All right. So here's where we need to kind of see what this thing looks like. Well, I know that this thing is a parabola that opens down. I know that. I'm not even going to draw an XY coordinate. I just need to see, does it open up or down? And we've got a vertex here of -4, -8. There's my vertex. Okay. So I need the range of this thing. So the range, okay, remember The domain, that's all the x values that the graph covers. And we know that if we have a parabola, it's going to hit all the x values. Okay, it's going the domain of a quadratic function is negative infinity to positive infinity. Now, I don't know if I said range earlier. If I did, I'm sorry. When I was talking about domain, I can't remember if I said range or not. But anyway, right now I'm talking about the domain. So the domain, that's negative infinity to positive infinity. That's all the x values that it's going to hit. Yeah, this thing's going down forever, but it's also going left and right forever. Okay, so the domain, that's negative infinity to positive infinity, which they don't ask us to find the domain, but I just thought I'd mention that. And then the range, that's all the y values that it's going to hit. Well, what all y values is this thing going to hit? Well, this y value here, okay, is at -8. You see that? -8. All right, and it's going down. So all the y values that this thing hits is from -8 all the way down to what? Negative infinity. So the range would be negative infinity to -8. See, it's going down. It's not, the y values, they're not going above -8, so it's not going to hit any of those values, just from -8 down to negative infinity. So negative infinity to -8. Now, is the -8 included? Yeah, that point right there includes the y value -8. And so that means we would have to put that in a bracket. Okay. And then it says find the maximum or minimum value of the function. Well, we can see since this opens downward, it's going to have a maximum value. If it opens upward, it would have a minimum. So this has a maximum value. So this has a maximum value at what? At -8 here. See that? All right. Now we want to see increasing or decreasing. So let's see increasing, and let's see decreasing. Okay, where's this thing increasing? Where is it decreasing? All right, so you notice that the graph is increasing here. Okay, it's increasing there. See, it's increasing, 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 and once it gets here, it starts decreasing. So you can see that it's increasing from where? From negative infinity, right? So it starts increasing at negative infinity, and it's increasing, 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 and then it stops increasing right here at where? At -4. And so there's the interval where it's increasing. Now you might be wondering, well, you know what? This thing stops increasing at -8. Okay? That's not what they're asking. When they're asking for the intervals where it's increasing and decreasing, they want to know over what x values is it increasing and decreasing. So I don't know if you could have seen me when I did this, when I pointed back over here when I said negative infinity. I wasn't saying down here it starts at negative infinity. It starts over here. So if I'm way out here at negative infinity, we can see this graph is as I'm moving to the right, this graph is increasing. You see that? It's way down here. See, this graph continues on down like this forever. And see, yes, it's going down forever, but it's also going to the left forever. So it starts increasing at negative infinity, and it's increasing, increasing, increasing. And then right here at this point, it stops increasing where x is -4. Okay. Now, let's see about decreasing. So where's this thing decreasing? Well, it starts decreasing at this point right here. when x is negative 4. So that's from negative 4, and it's decreasing, 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 all the way to where x is infinity. See, we're going to the right forever. And as we go to the right forever, this graph is decreasing. And there is your answer for all of those. Okay. All right, let's look at this next one. So we've got y equals 2x squared minus 4x minus 9. All right, so let's do just like we did. Let's go ahead. This thing opens upward. Okay, opens upward. Then they want to know the vertex. So let's find the vertex. So this one's in the other form. So to find the vertex, we've got to use this right here. We've got to find minus b over 2a. And then once we find that, we plug that value back into the function, and that gives us our y value for the vertex. All right, so let's go ahead and find that. So we've got minus b over 2a. That's going to be negative 4 over 2 times 2. See, b is negative 4. So that's negative b, which is negative 4, over 2 times a. 2 times, and a is 2. Just kind of like when you're plugging these things into the quadratic formula. And so the x-coordinate, that's going to be what? 4 over 4, which is 1. And so now we've got y of 1 is equal to 2 times 1 squared minus 4 times 1 minus 9. And so that is going to be, let's see, 2 minus 4 minus 9, which is negative 11. So our vertex is 1, negative 11. So there we go. So we found opens upward, and we found the vertex. Okay. So let me go ahead and just erase this work that I have here so we can move this vertex back up. So that's vertex is 1, negative 11. All right. So now we need our axis of symmetry. And let's go ahead and just make a rough sketch of this thing. It's a parabola that opens upward. There's the vertex, and the vertex is 1, negative 11. And look, there's your axis of symmetry. So remember, the axis of symmetry, that is x equal a number because it's a vertical line. Well, it's this vertical line here, x equal. Well, what is x going through? 1. So it's x equal 1. And then we need the range. All right, so the range, that's all the y values that this thing's going to hit. Well, what y values does it hit? Well, it starts here, right? And it goes up forever. So that's all the y values from this y value, which is negative 11. And the negative 11's included. And it's going up forever. And so negative 11 to infinity. And that's the range. And then we need to determine maximum or minimum value. Well, this is a parabola that opens upward. So this is going to be a minimum value. And it's where? Well, there's your minimum value, negative 11. And then we want to do increasing. And we want to do decreasing. All right. So this thing is increasing. It starts right here at x equal 1. And as I move to the right, this graph is going up. See, it's going up and to the right. So as I move to the right, it's increasing. So as I move to the right, I'm going to where? I'm going to infinity. And then decreasing, well, this thing is decreasing, decreasing, decreasing. Now, where does it start decreasing? Well, not only is it going up here forever, it's also going to the left. So it starts decreasing out here at negative infinity. And it's decreasing, 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 and then it stops decreasing here at x equal 1. And so this is what they're asking for in this problem. All right. All right, so let's move right along. I know this is a kind of a long video, but you learn a lot of stuff in this section. All right, so now let's talk about finding x and y intercepts. And look, all this that we're doing right now, finding the vertex, you know, and now these x and y intercepts, what all this is going to do, it's going to all come together in a little bit, and this is how we're going to graph these things. Okay, so to find the x-intercept, let y equal 0 and solve for x. And to find the y-intercept, let x equal 0 and solve for y. So in a college algebra class, you should have already done this by now. You've already found x and y intercepts. You just did it with linear functions, okay? Where you had something like this, y equals 2x plus 1. They asked you to find the x and y intercepts. It's the same thing, okay? Except you're just doing it with quadratic equations. Okay. All right. So let's go ahead and find the x and y intercepts. And actually, I need to change this problem up. Let's put a plus there so it works out a little better. All right, so find the x and y intercept. So let's go ahead and find the x-intercept. All right, so the x-intercept, let y equal 0 and solve for x. So basically, just to put this a little simpler, to find the x-intercept, set the function equal to 0 and solve for x. To find the y-intercept, plug 0 in for x and evaluate it. That's all you're doing. Okay. All right, so here we've got negative 2 times x plus 4 squared plus 8 equals 0. And so you've solved this before, okay? In the college algebra class, you've done this. So let's move the 8 over. So I get negative 2 times x plus 4 squared equals negative 8. And then I'm going to divide both sides by negative 2. I'm just getting this squared part by itself. So let's divide both sides by negative 2. And so that's going to give me x plus 4 squared equals 4. And then here I use what? I use square root property. So that's going to be x plus 4 equals plus or minus the square root of 4, which is plus or minus 2. So now we do what? Subtract 4 to both sides. And so I get x equals negative 4 plus or minus 2. So x is equal to negative 4 plus 2, which is negative 2, or x equal negative 4 minus 2, which is negative 6. So my x-intercept is negative 2. Okay, see, x is negative 2. Well, what was y? Y was 0. Okay, and my other x-intercept is negative 6. 0. So there's your x-intercept. Now let's find the y-intercept. So the y-intercept, well, we just evaluate this function here at 0. So y of 0 is equal to negative 2 times 0 plus 4 squared plus 8. And so that's going to be negative 2 times 0 plus 4 is 4, and 4 squared is 16 plus 8. And that is going to give us, let's see, negative 2 times 16 plus 8 is negative 24. And so the y-intercept, where it crosses the y-axis, well, remember, x is 0, and we got a y value of negative 24. And so there's your y-intercept. All right. All right, so now let's look at this one. Same thing. Let's find the x and y intercepts. So set this equal to 0. So I've got, well, let me write down x-intercept. So I get 2x squared minus 4x minus 9 equals 0. Now let's see, does this factor? I don't know. I'll have to, let's test it out and see. Well, let's see. So I know that's going to be 2x and x, and it doesn't, because if I put a 3 here and a 3 here, that's going to be 6 and 3. That difference isn't going to give me minus 4. And if I use 9 and 1, that's not going to work either. So this one doesn't factor. So what do we do when it doesn't factor? We can either complete the square, or we can use quadratic formula. Okay. Now, I guess here let's just use quadratic formula. So we know that A is equal to 2, B is negative 4, and C is negative 9. And the quadratic formula is x equal negative b plus or minus square root b squared minus 4ac all over 2a. And so all we do is plug each one of these in to the quadratic formula. So x is negative 4 plus or minus the square root of negative 4 squared minus 4 times a times c all over 2 times a. All right. And so this is going to give me x equals 4 plus or minus the square root. Now, when you do all of this arithmetic in here, that is going to give you 88. And that is over 4. Okay. And so now I think we can simplify the square root of 88. So x is equal to 4 plus or minus the square root, and that's what, 4 times 22 over 4, which equals 4 plus or minus square root of 4 is 2, so that's 2 square root of 22 over 4. And then we can see that 2 goes into each of these evenly. So 2 goes into 4 2 times, goes into 4 2 times, goes into 2 once. And so I get x is equal to 2 plus or minus the square root of 22 over 2. Now, what's my x-intercepts? Well, it's going to be what? It's going to be 2 plus the square root of 22 over 2. That's one x-coordinate, 2 plus square root of 22 over 2. Well, what was my y? Remember, y was 0. And 2 minus square root of 22 over 2. And my y-coordinate was 0. And so there's the x-intercepts. Okay. Now I need the y-intercept. Well, remember, the y-intercept is just evaluate this at 0. And so y of 0 is equal to 2 times 0 squared minus 4 times 0 minus 9, which is negative 9. And so x is 0, my y is negative 9, and so there's your y-intercept. Okay, so you can see finding the y-intercept, that's pretty easy. Just plug 0 in for x. Now, from this, you can see that sometimes finding that x-intercept can get a little more involved. Okay, so but just remember, x-intercept, set it equal to 0, solve for x. Y-intercept, plug 0 in for x and evaluate the function. Okay, so now we've got this solving an inequality, a quadratic inequality. They want us to write the solution in interval notation and graph it. All right, so to solve a quadratic inequality, you just want to move this, you want to get everything to one side and have 0 by itself. So I'm going to subtract 6 to both sides. So x squared minus x minus 6 is greater than 0. Okay, now as far as these problems go, if you need some more on this, solving quadratic inequalities, just go search my channel, Solving Quadratic Inequalities, video just on its own. All right, so the first thing we want to do, set this thing equal to 0 and find the zeros. So this factors. So that's x minus 3, x plus 2, x minus 3 equals 0, or x plus 2 equals 0. So x equal 3 or x equal negative 2. Okay, so you find the zeros. All right. Now what we want to do is we want to plot these on a number line. So if I draw me a number line, and I've got negative 2 and I've got 3, it breaks this number line up into 3 regions. Okay, breaks it up into 3 regions. And what I want to do is I want to choose a number from each region. So I'm going to choose x equal negative 3, x equals 0, and x equal 4. Okay, so there's my number from each region. Now you can pick any numbers you want. It makes no difference what numbers you pick, just as long as you have one that's in each of these regions. All right, so now let's look at this. I want to take each of these numbers and plug them back into my function here, my x squared minus x minus 6. I'm going to plug it into that. Now, hopefully you agree that this function is the same as this function, and just this one's factored. Okay, that's the only difference, it's factored. So it makes no difference which one you plug it in. You can plug each of these into this one, or you can plug them into this one. Same thing. Now, look at this. If I take the negative 3 and plug it in for x, that's negative 3 minus 3 times negative 3 plus 2, right? Now, do you agree that whatever I get here, that's negative? It's negative 6, right? And whatever I get here is negative, it's negative 1. But I don't care about the negative 6. I don't care about the negative 1. I don't care about that. All I care about is it's negative and negative. What's a negative times a negative? Positive, right? Okay, that's all I care about. When I plug these numbers in, am I going to get a positive answer or am I going to get a negative answer? That's all I care about. I don't care that it's going to be positive 6. That makes no difference to me. I just care about it's positive. Okay. So now let's do the same thing. Let's plug the 0 in. 0 minus 3 is negative. 0 plus 2 is positive. So that's a negative times a positive is negative. And then I plug the 4 in. 4 minus 3 is positive. 4 plus 2 is positive. Positive times a positive is positive. Okay? All right, so hopefully you're with me. Now, if that's confusing to you, just plug the numbers in, see what answer you get, and see if it's positive or negative. Okay? All right. So now, let's see, what are we wanting to know here? Well, we're wanting to know, when is this greater than 0? Well, what does greater than 0 mean? It means positive, right? Isn't that what greater than 0 is? Positive. So that's what we want to know. When is this function positive? Well, it's positive here and here. You see that? So so this function here is positive from negative infinity to -2. And I'm going to have parentheses because it's not greater than or equal to. Now look, if this symbol was or equal to, this would have a bracket on it, okay? But it's not. There's no or equal to, it's just greater than. So that means this is a parenthesis. So from negative infinity to -2, or what? 3 to infinity. So that's your solution there. And they did say graph it. So let's graph this thing on the number line. So there's, let's see, 0, -1, -2, -3, 1, 2, 3, 4. So this graph is what? From -2 all the way back to negative infinity. Now, is the -2 included? No. So we're going to have a parenthesis on that because the -2 is not included. And then here on the 3 to infinity, that's 3 all the way back to the right. And we will have a parenthesis on that also because the 3 is not included. Now, I used a parenthesis here. That's the same thing as using an open circle. Okay? If this were equal to, you would have brackets here where I have the parentheses, or you could use the shaded in circles. Now, back when I took my math classes, I learned the open circle and closed circle to do the graphs. So you might be wondering, well, why are you doing parentheses and brackets now? Well, that's how a lot of the textbooks are using the parentheses and brackets now. So I'm just going to stay consistent with those. Okay, but you know, if you use open and closed circles, that's fine. All right, but yeah, but here's the answer to that question. Okay, but like I said, check out my channel. I got more videos on. I got another video on just this. Okay. All right, so now we come to the fun part. We get to graph these things. All right. Now, when you're graphing these things, I know I just have graph here in the directions, but what they want you to do when you're graphing these things, a lot of the directions you'll see in the textbooks is graph by finding the vertex and the intercepts. Okay, and that's how we're going to graph these things. We're going to graph these. We're going to find the vertex. That's the first thing that you always want to do. You always want to find that vertex first. Okay, find the vertex, and then find your x and y intercepts, and then sketch the graph. Okay. So first thing, we've got vertex. So the vertex is 3, -8. So that's easy. It's in this form, HK. Remember, H has the opposite sign, K has the same sign. All right, so now let's find the x and y intercepts, which we worked a couple of problems like that earlier. So let's go ahead and find our x-intercept. So we've got 2 times x minus 3 squared minus 8 equals 0. I want to get the squared part by itself. Complete the square. I'm sorry, not complete the square, but use the square root property once I isolate the squared part. So that's 2 times x minus 3 squared equals 8. Divide both sides by 2. So x minus 3 squared equals 4. So I get x minus 3 equals plus or minus the square root of 4, which is plus or minus 2. And then I'm going to add 3 to both sides. So x equals 3 plus or minus 2. So x equals 5 or x equals 1. 3 plus 2 is 5. 3 minus 2 is 1. And so my x-intercept, 5, 0. And 1, 0. All right. Now let's find the y-intercept. So I think what I'm going to do here is I'm going to rewrite these. I'll rewrite my vertex. I mean my x-intercepts up here, because I'm going to have to scroll down and it'll cut it off. So here's my x-intercept, and let's go ahead and just maybe put a star by these important points here. So now let's find the y-intercept. So the y-intercept, that is y of 0, which is 2 times 0 minus 3 squared minus 8. And so that is going to be 2 times, and that's 0 minus 3 is negative 3. Negative 3 squared is 9 minus 8. And so I'm going to get, what was that, 18. 2 times 9 is 18, minus 8 is 10. And so that's 0, 10. There's my y-intercept. All right. So now let's go ahead and sketch this graph. And so let's see. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And I'm going to have to be able to take in a y value of negative 8. And I'm going to have to be able to take in a y value of 10. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then 1, 2, 3, 4, 5, 6, 7, 8. So we know this is 10 up here. This is negative 8 here. So now all we do is we just plot our points. So I've got 3, negative 8. Okay, 3, negative 8. I've got 0, 10. Okay, 0, 10. I've got 5, 0. 1, 2, 3, 4, 5, 0, and I've got 1, 0. Okay. And so now we draw our graph, and I know this isn't going to look the best in the world, but so there's your parabola. Okay. And yes, it would look much better if you use graph paper. You know, if you've got it, you know, you can use it. If you don't have graph paper and you want to use it, but if you don't have graph paper, you want to use a graph paper, but you don't want to go out and buy any, just Google graph paper and print it out. Okay, but there's your graph. Okay, so let's look at another one. All right, so and one other thing I want to mention here also is with this problem, just looking at it, we knew that it was going to open up because we have a positive in front of our squared part, right? So we knew it was going to open up. Now let's get down here to this one. I think what I'm going to do is I'm going to move this right here up some in case we need more room, because I got another one I'm going to graph after this one. All right, so we know this one's going to open down, right? So let's go ahead and find the vertex. So our vertex, let's see what we've got. So this is in the other form. So for my x coordinate, I've got to have minus b over 2a. So that's negative 4 over 2 times negative 1. See, a is negative 1, b is negative 4. A is the number in front of x squared, b is the number in front of x. And so this is, let's see, what is that? Let's see, 4 over negative 2, which is negative 2. So there we go. All right. So there's our x coordinate. Now let's get our y coordinate. So our y coordinate is y of negative 2 is negative 2 squared minus 4 times negative 2 plus 5. All right, so let's see. That's going to be negative 2 times negative 2 is 4, but a negative in front, so that's negative 4 plus 8 plus 5, which is 9. And so there's your vertex. Let's put a little mark by that because we're going to use that point later. We're going to plot that point. Now let's find the x-intercept. So I'm going to take my function, negative x squared minus 4x plus 5, and I'm going to set it equal to 0. Now we're solving a quadratic equation. And remember, whenever you solve a quadratic equation, you don't want that negative in front of the squared term. So we can fix that real easy. Just divide everything by negative 1. So x squared plus 4x minus 5 equals 0. And so this factors into x plus 5 minus 1. Yep. And so x plus 5 equals 0, or x minus 1 equals 0. So x equal negative 5 or x equal 1. So my x-intercepts, that's negative 5, 0, and 1, 0. Okay, so there's my x-intercept. Now let's find the y-intercept. So the y-intercept, that is y of 0, which is negative 0 squared, minus 4 times 0 plus 5, which is 5. So that is 0, 5. Let's go ahead and put stars by these because that's what I'm going to be using, those points. All right, so all I did to find, remember, all you do to find the y-intercept is you just plug 0 in for x, just evaluate the function at 0. All right, so now I think we're ready to graph this. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9. See, I've got to be able to plot the point negative 2, 9. And then let's see, 1, 2, 3, 4, 5, because I got to go to the left 5, and then 1, 2, 3, 4, 5, 1, 2, 3, 4. All right, so now let's just plot our point. So I've got the point negative 2, 9. Let's see, negative 2, 9. It's right there. It's kind of hard to line these things up on this tablet, but all right, so then I've got negative 5, 0. I've got 1, 0. And I've got 0, 5. 1, 2, 3, 4, 5. Okay, so there's your points. So let's go ahead and draw our graph. And there you go. All right. Now, sometimes you can make careless mistakes. I hope I haven't made a careless mistake in this video, but sometimes you can. Okay, you can evaluate it wrong, just make a stupid mistake. Now, one thing you can do is, if you do make a stupid mistake and you go to plot these points and you plot your vertex, you plot your x and y and your x-intercepts, and then you go to plot your y-intercept. And if you plot your y-intercept and it's way down here or it's up here, then you know you did something wrong. Okay? Or if you plot your x and y intercept, okay, and then your vertex is way over here, then you know you did something wrong. Or if you plot your x and y intercept and your vertex is down here, okay, well, then you know you did something wrong. So you can kind of tell from plotting the points. All right, so now let's look at this one. Let's graph this, same thing. So let's find the vertex. All right, so I've got minus b over 2a. So that's going to be negative 6 over 2 times 1, which is negative 3. So there's negative 3. And then let's see, y of negative 3 is negative 3 squared plus 6 times negative 3 plus 11. And so that is going to give me, let's see, so negative 3 squared is 9, and 6 times negative 3, that's minus 18 plus 11, and that is 2. And so there's my vertex. All right, now let's find the x-intercept. So I've got x squared plus 6x plus 11 equals 0. Okay. Now, this thing doesn't factor. Okay, so we've got to use quadratic formula. Yes, there's on some of them you may have to use a quadratic formula, and your x and y intercepts don't come out so nice. Okay, that happens sometimes. All right, so earlier we found x and y intercepts, and in that problem, the function wouldn't factor, and we used the quadratic formula. How about in this problem, we complete the square? Okay, let's do that. Yes, you can throw this into the quadratic formula, get the same answer. Okay, but since I showed the quadratic formula in the first one, let's do completing the square on this one. All right, so remember I've got x squared plus 6x, move the 11 over, equals negative 11, leave a little space here. So we take half 6, which is 3, square 3, that's 9, so plus 9, and then this is x plus 3 squared equals negative 2, and so x plus 3 equals plus or minus I square root of 2. Uh-oh, look what happened. We get an imaginary solution. What in the world does that mean? No x-intercepts. Okay, so there's no x-intercepts. Now, think about this. I went through all of this trouble, and we all know that we don't like to do more work than what we have to, right? We know that. If we would have thought about this a little bit more, we would not even had to have done this, would we? Look at this. Here's my vertex. Let's just real roughly plot this. Negative 3, 2. There's my vertex, right? I go to the left 3 and up 2. Look at your function. That's a is positive, right? Which way does this thing open? Up. You can see it's never going to cross the x-axis. You see that? But in case you forget to do this, and you go and set it equal to 0 and solve, and you get that imaginary solution there, no x-intercepts. Okay? All right. So x-intercepts, none. Now let's do the y-intercept. So y-intercept, that's going to be y of 0 is, that's going to be 0 squared plus 6 times 0 plus 11 equals 11. So y-intercept 0, 11. All right, so let's plot them. Let's plot these points. So let's see, we've got this. I'm going to put the y-axis way down here. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I know this is 11, and then I'll also need the 2, and then 1, 2, 3, 1, 2, 3. Okay, let's just put some more points there. And look, you know, the graphs don't look that good because these marks I make, obviously you can tell they're not equally spaced. You know, you can take your time and do all that or get graph paper. So let's plot negative 3, 2. So there's negative 3, 2. And then 0, 11. 0, 11. All right, so now we've kind of got a little problem, don't we? We don't have but 2 points. And in the past, when we've had 2 points, we just connected them with a straight line, didn't we? Okay. So in this one, what are we going to do? Well, if you remember at the very beginning of the video, I know by now that was a long time ago, but at the very beginning of the video, do you remember when I had something like this? I had the axis of symmetry, and I told you this graph was a mirror image about that axis of symmetry. That's what we're going to do. Since we have just the vertex and one other point, we're going to mirror that point over. Okay? So let's draw in our axis of symmetry here. Okay? Now look at this. Notice this point, if I go straight across to the axis of symmetry, how many units did I go? 1, 2, 3. So that means if I go straight across, if I keep going straight across, 1, 2, 3 more units, there's another point on that parabola. So I just mirror that point over, and now I can draw in my parabola, and there it is. Okay. Now, one thing that you've got to be careful, I see students do this all the time when they draw their parabola. Notice how I've been drawing the parabolas like this. I see some students when they draw these parabolas, they'll draw them like this or like this. That is not a quadratic. That's not the graph of a parabola. That's the graph of absolute value. If you draw a parabola and you make it a point, that is wrong. Okay? If you're in my class, I'll take points off for it. Okay, so remember it's rounded there. All right, so believe it or not, we're almost done. Okay, we don't have a lot left. So here it says a ball is tossed straight upward with an initial velocity of 80 feet per second from a rooftop that is 12 feet above ground level. The height of the ball in feet at time t is given by this function right here. H of t is negative 16t squared plus 80t plus 12. Find the maximum height above ground level for the ball. Okay? All right, so I think we can do that. So let's just think about this for a minute. I want to know the maximum height of the ball. Okay? So, if you graph this thing, we know that this graph is a parabola that opens down. Okay? I'm not putting the XY coordinate system on there because I don't know exactly where the graph goes. Okay? I would have to find the vertex and all, and X and Y intercepts and all that good stuff. But let's just use this for demonstration. Now, if we did put an XY axis, that would be T and this would be H. See, T is like your X, H is like your Y. T represents the time, the number of seconds that the ball is in the air. Okay. H represents the height of the ball at any given time. Okay. So you can see right here, that's your maximum height. This is TH, right? Now, see, remember, when you had this, and this was an XY coordinate, your vertex is an XY point, right? Well, T is like your X, H is like your Y. Okay? So, if I find what I've got to find is this maximum height here. And what is that maximum height? That's H. Okay, that's H. But in order to find H, I need to find T. At what time does it reach its maximum height? At what time does it reach its maximum height? So when I find the T, I plug it into here, and that will give me the maximum height. So look, all this is T equals minus B over 2A. Right? I'm just finding the vertex of the parabola. In this case, this parabola opens downward, and I'm I'm finding the maximum. Okay, that's the vertex when a parabola opens downward, you find that vertex, that's a maximum. And so in this case, b is 80, so that's negative 80 over 2 times negative 16. And that is going to be, put that in your calculator, you get 2.5. So that is this t value here. Okay, that's at what time. Now to find h, I'm going to plug this in for t. So h of 2.5 is equal to negative 16 times 2.5 squared plus 80 times 2.5 plus 12. And that ends up giving us 112. And so it's 112 feet, right? 112 feet above the ground. That is the maximum height above ground level for the ball. Okay. All right, so let's look at this one. Well, look, this is the same thing. Let's see. If 100 meters of fencing will be used to fence a rectangular region, then what dimensions for the rectangle will maximize the area of the region? So we want a maximum area. And nice of them here, they give us the dimensions of the rectangle. Okay? And I want to do what? I want to maximize the area. Well, remember the area of a rectangle is what? Length times width, right? Length times width. You see that? So, what do we have here? So, what's the length? L, 50 minus L, it doesn't matter. One's length, one's width. We'll say L is the length, and we'll say this is W. Okay? Now, that's going to be length times width. You see that? And so that's going to be what? 50L minus L squared. So the area is negative L squared plus 50L. Okay. There's my quadratic. It's quadratic. And I want to know the dimensions that give me a maximum area. So that's just the vertex. So let's do L. See, L is like my X. A is like the Y. And so L, that's going to be what? Negative B. Well, let's write the formula down. Minus B over 2A. So that's negative 50 over 2 times negative 1. So that is going to give me what? That is 25, right? Okay. So this dimension is going to be 25, and this dimension is going to be 50 minus 25, which equals 25. So the dimensions that give me a maximum area, and let's see, this is in meters, so that's going to be 25 meters by 25 meters. It's a square. Okay. All right. This is the last problem. There's 2 parts, but it's easy. Identify the solution set by inspecting the graph. So this graph is x squared minus 2x minus 3. If you took x squared minus 2x minus 3, you graphed it, this is what you would get. And they want to know, when is this greater than or equal to 0? When is it greater than or equal to 0? Well, look. Isn't it positive here and positive here? See? See that? The graph is above the x-axis. It's positive. Okay, when are the y values positive? Well, let me go ahead and write this. That's -1, and that's 3. Okay, so this is going to be what? -infinity to -1. Now, is the -1 included? Yes, it is. So that's a bracket. Or from 3 to infinity. Okay. That's where, because this thing is just rising forever, right? It's going up forever. But not only is it going up forever, it's going to the right forever. Not only is it going up forever, it's also going to the left forever. Okay, so there's the answer to that one. Now, what about this one? See if you can write that answer down. Well, when is it less than 0? In other words, when is the graph negative? Well, do you see that it's negative right here? When it's below the x-axis? So when is it negative? It's negative from -1 to 3. So from -1 to 3. But oh, look at this. We've got parentheses on it because it's not less than or equal to. All right. So this video was kind of long. I expected it to be, but I hope this makes sense. I mean, the really important, I mean, all of it's important, but the main thing is knowing how to graph these things. Okay, you've got to know how to graph them. And remember, to graph quadratic functions, you find the vertex first, then you find the x and y intercepts. Plot them, draw your graph. If you don't have x-intercepts, mirror that y-intercept over. Okay, a parabola that opens up and down like these, it's going to always have a y-intercept. Okay, it may not always have an x-intercept. Okay, now you might be thinking, well, is there any time where a graph won't have a y-intercept but always have an x-intercept? Yeah, the ones that open left and right. Okay, all right, so I hope the video helped. Check out my other videos. Give me a like, share, and subscribe, and thanks for watching.